Operating DC motors in some industries like pulp and paper is a challenge. Keeping brushes performing requires an understanding of many factors. Many things make up brush performance: grades, springs, commutator condition, holders, commutator temperature, and air quality. Air quality is a huge factor when it comes to maintaining commutator condition and brush performance. This commutator condition is poor. Many things have gone wrong. Notice the scale. The deterioration of the bandings due to heat and burning. This motor should have been replaced long before it reached this condition. The H2S in the air has created this scale deposit on the commutator. It's the bad environment that's caused all this. This scale must be removed during PM opportunities, and don't let it collect on these paths. Also, the banding has deteriorated. It's been burning. It's also been overheated. This motor certainly should have been removed earlier. More evidence of scale deposit on this commutator surface due to the corrosive air environment. Sometimes areas near the risers are missed during PMs and not cleaned properly. This scale formed on the commutator surface is somewhat conductive. That leads to shorting bars out, especially at this riser area. What's supposed to happen is a film should be deposited on the commutator as the motor is operating. This film helps with lubricating the brush as it glides over the commutator. A properly operating brush with good cooling air quality will develop a film between the brush and the commutator. Commutator film makeup is here. Copper is made up of 75% copper oxide, some grains of moisture, 5% air contaminants, and carbon graphite from the brush itself, around 20%. There are 4 main brush grade families. 2 popular brushes used in the paper industry are the graphite and electrographite brushes. Electrographite brushes operate at higher current densities, which means you can flow higher current per area of the brush face than some other grades. Electrographite brushes can operate upwards of 80 amps per square inch and can even operate at up to 100 amps per square inch for shorter periods. I use electrographite brushes in many paper mill applications where air quality might be somewhat compromised. Applications like wet-end motors on a paper machine is such an example. A few popular electrographite grades of paper industry when dealing with contaminated environments are the N66, the T566, the T567, and even the L932. N66 has some polishing action. The L932 has more and should be used for areas that have high chemical vapor contamination. Grade T567 is a new impregnation that was created just a few years ago to give longer brush life in paper mills. T567 is the same base carbon as the grade T566, which has been around for more than 30 years. Graphite brushes are great at filming if the environment is good. I don't use these motors in areas where air quality is compromised. Current density range for graphite brushes is 45 to 65 amps per square inch. They are not capable of sustained operation at higher current densities like electrographite brushes are. I just have not been successful operating these when air quality is a problem. Brush face temperature influences the wear rate of the brush and the commutator. Too cold and too hot lead to increased friction. The middle is the desired range. Too much brush friction prematurely wears the brush uncalm. Brush friction is influenced by, as we said, temperature, spring force, current, the commutator condition due to the atmospheric conditions, surface film, and speed. Abrasive classification is the ability of the brush to clear the scale off the comb. It comes in three different classifications. Low indicates very little abrasiveness, medium, somewhat cleaning action, and high, significant cleaning action. For any brush, it is extremely important to satisfy the current density range of the brush grade you've selected. This might require operating with less than a full complement of brushes. Each brush grade has a current density range or current carrying capacity. The current density can be calculated by taking the total number of amps and divide it by 1/2 the number times the area of the brush. Rubber hard-type brushes have a pad on the top designed to soften the impact of a rough running comb, give longer brush life, and reduce brush breakage. They do not address the root problem with the commutator. Here is some typical information that is available from your brush manufacturer. There's a data sheet for all brush grades. Brushes with higher resistivity, like electrographite brushes, are better at commutating than those with lower resistivity. However, those would also have higher contact drop and therefore more heating. To determine the grade and quality of brushes to run on your motors, it requires a current density study be performed at your facility. Brush manufacturers will provide that service, and they'll do a really good job. However, the data given to them must be accurate for the study to be effective. And here's a worksheet that I use when determining the number of brushes to operate. Brush pressure is measured in pounds per square inch. There's a recommended brush PSI range table. Here it is. For general industrial motors, its recommendation is to run between 3.5 to 6 PSI on your brushes. Upper end is best for industry like paper mills due to the atmospheric conditions affecting the comb surface. A less loaded spring can lead to brush lifting and continual deterioration of the commutator. So I like to run at the 6 PSI range. We said brush pressure is measured in PSI. Springs are, however, measured in pounds of force. To determine the spring force required for a certain brush, multiply the desired PSI times the area of the brush. If the spring force is known, to find the PSI, divide pounds of force by the area of the brush. We said we want to stay closer to the 6 PSI end of the range for applications with contaminated air source. When measuring spring force, remove the shunt from the brush arm connection, connect a force gauge such as a fish scale, and pull the brush in a direction that is in line with the holder. Pulling at an angle with the holder will cause an inaccurate reading. To check the spring pressure, we use a scale that measures force, just like a fish scale. And you have to remove the shunt from the connection and straighten it out, hook the scale to the shunt, and pull straight up on the brush shunt, and release a paper that's underneath the brush. When you release the paper, read the scale, and that one is saying 5.52. Now, if you didn't use the paper and you just pulled on the scale without the paper, it's going to read a little bit higher, and typically it's almost a pound higher by measuring it that way. And yeah, this time you can see that the scale measurement was around 6.2. So you get a little higher reading without using the paper. Spring pressure is extremely important. If too light, the brush will not stay down. Any lifting of the brush will result in arcing and electrical wear. If pressure is too high, mechanical wear will be the result. We have seen that in a contaminated environment, we will develop scale on the comb. The brush pressure must be sufficient to facilitate the removal of the scale. So here's some brush spring tips. Never mix brush spring pressure. That'll cause selectivity. With contaminated environments, use the high end of the recommended range of 3 to 6. Use the 6 psi range end. That helps keep the brush down and better cleans the commutator. Never sandblast springs. PM spring that is needed and includes checking the pressures, looking for breaks and damage. Broken and damaged springs can indicate problems with the comb profile, brush alignment with path, or even an incorrect holder angle. For springs to work, holders must be clean and brushes must be able to move freely. Brush holders. Brush holders should be the same distance off the comb, between somewhere around 60 thousandths to 90 thousandths range. Brush manufacturer will give you a card to place under the holder to adjust that height. One manufacturer uses 78 thousandths thickness card. These should all be set the same at the shop prior to the motor arriving at your facility. If the brush holder setting is too large, it could cause the brush to become unstable and it could promote friction and chatter. Watch what happens to the alignment of the brush center to the neutral plane as we move the brush holder. We'll start with the brush holder in this position. As the brush holder is now lower, the center line of the brush becomes a little bit offset from the neutral plane axis. And here you can see the result from lowering the brush holder, and the center line of the brush is now offset from the neutral axis. Any brush face movement within the holder will result in a change in the contact surface. The most stable surface contact will occur when the top and the bottom of the brush are held against the same side of the holder, regardless of whatever direction the motor is turning. Angle holder mountings were developed to increase this stability and the effective area of the brush contact. Stability will occur only when the correct angles are used in relation to the direction of rotation. When the entering edge is the short side of the brush, this side, the face angle should be 20 degrees or less. At angles greater, the action of the rotation and the spring force wedges the brush into the bottom corner of the holder right here in this area and causes high friction and unstable contact. Normally, brushes in operating in this orientation also have shallow top bevels. When the entering edge is the long side of the brush, the face angle should be 25 degrees or more. At angles of 20 degrees and less, the action of the rotation pulls the bottom of the brush to the opposite side of the holder from the top of the brush. Normally, brushes operating in this orientation should have a top bevel of 20 to 30 degrees. A stable contact can be maintained in either or both directions of rotation when the face angle of the brush is between 20 and 25 degrees. This holder is actually 33 degrees, so this is best installed when rotation is in the long side of the brush. Question: what happens when we are installing a motor with the holder face angle of 33 degrees and the rotation is into the short side? Well, some people would send the motor to the shop for reorienting the brush holder. In other words, flip the holders over on the other side of the brush stud and then reset the neutral. Now, this is best done at the shop so that the motor can be set up, the brushes can be installed in the correct manner, and then the bidirectional neutral method is ran to set the neutral. For proper symmetry, the brush holders must be equal distance all the way around the armature. Sometimes we can measure this by putting a narrow printing paper around the commutator and mark each tip of the brush with a pencil. Remove the paper, then flatten it out on the table and measure between those marks, and they should be equal distance. When we replace brushes, we should seat the new brushes using sandpaper or garnet paper. Never use emery cloth. Emery cloth has a synthetic or metallic particles, and we don't want those particles embedded in our brushes, so do not use that. When you finish seating the brush, you can take dry air and blow the sand and the dust out, and the carbon dust out of the motor sideways. Never blow it back in towards the riser. Always blow it away from the riser and out the motor.